As soon as I get access to the goddamn, come on. We are live. Where's my video so I can link it? I can manually construct the URL. I know. Yeah, okay, we're gonna have to manually construct this URL here. Oh, no, there it is. Everything's slow. https://YouTube. Hopefully that is the correct link. Boom. We did it, Reddit. Get that shit out of here. Put my keyboard in the correct spot to not feel like shit. Then see how hot my tea is and if I need more honey before it cools off. That's almost perfect. The next batch will be better for sure. Hello, world. And no, you mean hello, hunter. We don't hello world in this household. So I'm going through the old parser to see what things I need to make sure we handle here correctly. So parse statement has a bunch of things. I'll put this off to the side and you'll see, hello local, that also works. Not as cool. We have compounds, but we don't have them in the right spot. So compound, we need assert, return, we need if, for, while, hello hunter, there we go. Defer, we already have return, break, continue, yield, go to, Zizzy, my favorite, I forgot about Zizzy. Then assignment, we'll call it simple assignment, and then operator assignment. That good master local. I'm 50-50 on being called master. That could be a sexy thing. Now, if you're just being formal in Parsing and you want to call me master local, that's fine. But not like, master local? Ooh. Don't do that. Blueberry tea. So we have assignment and just straight up so those are the statements that I had in the original parser. There's probably a couple more because, oh, we need a while and a do while. I don't have, yeah, I never parsed a do while in here, I don't think. So while, do while, and then in expressions. One of the last things here we have maybe is a do expression. Then for each, how does CBQC always do lists? Constructors in Laie, Hibiku, I have no idea. By constructor, I mean the constructor expression, which should look like int for foo is 1, 2, 3, 4. Right, constructors can either be named like my field name, the compiler itself. What do you mean? Oh, you mean the C versions of the compilers? What vector type or what list type do they use? I've shared it before. Oh my god, OBS just shat itself for a second. somewhere in here, let's find append or push or something over. With a big list of macros and a single function to expand it. That's all the code necessary to expand a vector, which is in the repository in LCAH. You can find it. LCATA maybe expand. All of the macros, and then you just say element pointer foo is null. And then you use all of those macros to manipulate it, and that's it. It's a ye old header with count and capacity, and the pointer stores the data, and you just manipulate the pointer through macros. Okay, so I'm starting to put together a big reference of things that I need to do so I don't forget about them. We need parse decl. We do have a parse declaration. We have import struct test. Did I not have enum? I had to have had an enum. Did I never do enums in the old one? Never did enum. So struct enum alias test. I need to make sure that I do attributes. So that's going to be export. And I also want template parameter list templates. Move these down here. Export foreign call conv. I have a few more, so let's go see. Attributes. Export discardable and inline. Inline, discardable. Things are probably going to be no discard by default. We might have a purity system, maybe not. I haven't decided entirely yet. Foreign call conv, that's about it. Okay. So in still just constructing a list of things to do here, and then we'll have things to do. So what other expressions do I need? So when I do this, you go straight from primary to binary. And within binary, I just go straight back into primary. Do I have a secondary in here? I don't. So that's basically it. Binary is the only real secondary. There might be other cases that I need to check, but that's it for non-primary expressions. I think that's all the types we need. Hold on, let me go semi-types. Type info is a maybe. Pointer, buffer, reference, nillable type, that's right. Slice, array, buffer pointer, reference, nillable. Error pair, struct enum alias, those are declarations. Test, template parameters, whatever. I'm still iffy on module declarations. I've added the keyword just in case, but I might not actually do them because I can kind of get around question mark what I wanted with if I go back into not.studio.h, but studio stood lib lie. There, that one. I can get around it by just being explicit with all of my export imports, right? It's a bit big and annoying, but it's there. So maybe for the time being, we don't worry about the module declarations because they'll make SEMA very complicated. Well, not very complicated, just an extra step in SEMA. Okay. So then let me do another thing here. That's a big one. That's a big one. Yeah, this blueberry tea needs more blueberry. It's just blueberry flavored water right now, which I guess is all blueberry tea is. So, what do I need to do to get this shit tested? I might go ahead and start with this precedence parsing test. So if I go into parse name ref here, the first thing I've got is this template argument thing being a nightmare. So what I think I want to do instead, if at token kind less, right, we're just going to do this. So what we actually want to do is try advance. I'll actually just call this if try advance. Try advance this out var token less. Then we have access to the token. We are no longer at the token. We are then going to var. I need to parse an expression, but I need to ensure that its precedence cannot ever go below. So var RHS equals parse. Here's the thing. It needs to be an arbitrary expression. Here's the next thing. Parse context default. I could just pass in. Here's what I think I'm going to do. We're going to say template arguments. Our context is going to be template arguments, so I don't have to worry about passing precedence all the way through. When I get down to parsing a binary expression, what I want to do is in the parse context, or rather, let me change this because this is hard to read. Out int next precedence. Oh, don't want that. Right, which then needs out int out next precedence. Just to be more explicit where this is coming from, because it's not in the same page. If parse context is equal to template arguments, then precedence equals token less precedence plus 1. It actually needs to be precedence is math max precedence and this. and this can be out int. That's what I was looking for. If we're parsing template arguments, ensure we never allow arguments with precedence less than or equal to less and greater. Now, here is a problem. Saraid's probably not here right now to hear the problem, but there are more operators with different precedents that aren't those that we still need to think about. So if I bring my token kind over here in my operator precedence parser, we need, this is going to be a problem. This is going to be a problem. Let me go ping him, see what he thinks. Boom, message sent. I'll try to actually keep that on my screen in case he replies. So many things on my screen. So I think what we're going to actually have to do is, it at minimum needs to be pluses precedence. And not only does it need to be pluses precedence, I need to know somewhere what level of template parsing we're at. Because if I'm nesting templates, if I'm nesting template arguments, I need to be able to consume a greater, right? A right shift. So if I come over to here, I have a vec2 of vec2 f32. I don't know why you do that, but then we have a greater. So somewhere in here, I need to be keeping track of how many template argument parses are happening, and I need to be able to break out of nested template arguments. So bare minimum, this will handle. I see we're parsing templates. Yup, and I've pinged you in Discord with some of the things I just started discussing that are going to cause, not problems, they're doable, I just don't know how to do them yet. This is biggest problem. I need to figure out how to architect the parser such that this is not a problem. So I'm going to have to change my name ref thing here. Basically, well, I'm going to have to change it anyway. So that's a Not quite. Yes, that would be a problem, but we just fix it with a less b greater c is what we're looking at here. This being the thing we're causing problems for, not really. In one sense, we can totally allow this, but in the other sense, this is the problem. And if we disallow this, then this fixes the problem. So that's less the problem. The problem is unparenthesized. A less b hits greater. In this case, that's invalid. It'll be an error regardless. But in a case of this, that's what I'm worried about. Greater is now allowed to close two opening templates. Yes, which is what I'm starting to figure out how to do. Basically, I don't know how to exit multiple template parses. I can enter multiple, but I'm not sure how my parser is going to exit multiple template parses. So if we go parsing a name ref, we're entering the parse in parse name ref, which is just double colon separated names, optionally suffixed with the token less to start template arguments here. I'm probably going to have to parse template arguments in a parser function like this. So I'm going to quickly remove this. Yes, that was my first thought, and what I'm probably going to do to simplify my life. I was seeing if I could get around that. Because if I can just exit two parsers at the same time, that saves me having to split tokens. And I don't necessarily want to split tokens in, like, this case. I'm wondering if it's worth even trying to split this token. I can. Especially since we're trying to avoid rewinding the parser at all. Splitting the token isn't a terrible thing. But this is already going to be an error anyway. If I have foo here, even if we split the token, AB greater than foo doesn't make any sense in the first place. But we'll probably have to do that, yeah. We'll probably have to split the token. So I think we'll just focus on splitting the token and call it a day. So here, we're trying to determine if this is going to be a template argument list or not. And parsing a template argument itself is something I should definitely let's say if is definitely type start, because that's going to cover more cases. Parse the type. Then, if we can't do that, parse in template argument context, which handles precedence for us. Then here, we are going to parse a template argument, which handles this shenanigans for us. Then, what we want to do is, let me say do, and we can call this arg, while we are at, I don't know why it likes to do that, while we're at a comma, do that. Simple as. That's our while try advance even. While we skip commas, parse a template argument. So then one thing I want to double check that I'm doing correct is in primary expression. When we're parsing an open paren, this is the default parser context. Good. So that solves that problem. So then back up here, parse the template argument while there's a comma. Then I want to I want to know if this needs to be broken out of, basically. So maybe this is the second stage, and the first stage, we don't do this, because we want to check if we hit a comma, if we are at a comma, or we are at any of the potential closing delimiters. Right. I'm just trying to visualize this, because in the simple case, foo to bar, if we're at a greater, or if we're at a comma, then we've decided we are definitely in a template, for sure. So, token kind greater. And in the way that we're handling this, it sounds like we also want to, anything that starts with a greater should be handled as well. So if we're looking at our token kinds, we have greater and greater equal, which are both at the same precedence, so that's fine. And then we have greater greater. We're going to also have greater 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 at 30, and we're going to start parsing at 40. So all of the graders are going to be, can I use LCA, which is the license, but sure, yeah. Token kind greater greater, token kind greater greater. So I probably want to have a function here that's just like fucking private bool at potential template argument closer, which is then just going to return all of these for me, so I don't have to think about it all the time. Which technically doesn't matter, actually, because this is the only place that I'm going to do it. I'll need this check twice, but different. So greater greater greater. We're then also going to have token kind greater equal then greater greater equal then greater 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 equal. All of those start with greater. Right. So if we're at any of those, we're going to just decide flat out. The only thing we can be doing is parsing a template. If not, if we're not at any of those, we're going to early out and return some binary parser. So we're going to say var binary node equals new, or just binary is going to be equal new syntax binary. And that's going to take our name ref that we haven't created yet. So var name ref is going to be this. We're going to create a name ref with no template arguments. We're going to say the name ref is the left hand of the binary, the arg is the right hand side, and token less is our operator. And then we can return parse binary expression on our binary with the parse context default, our binary operator we just constructed, and the precedence of, why isn't it like that? Oh. Like that. With the precedence of equal to token kind less binary operator precedence.